Welcome to another cringy Mr. Billick video that he really doesn't care about. This is only to help you, and you either watch it or you don't. Class, this is going to be for astronomy. I can't even spell astronomy. Astronomy, this is going to be Unit 3. So if this is for bio, stop watching it. This is like pretty much just me talking about before class or even the day of, like, these are the three things that you really need to know. Put a star next to these because I'm literally looking at the test as I'm looking at this. You need to know Kepler's three laws. All right, I'm not really going to go over those, but you need to know his three laws for sure. All right. You need to know, if I put the sun in the middle here, there was something that a philosopher thought these little loop-de-loops were, and that's what I call those. What are those loop-de-loops called? And also, we got to put the sun, we got to put a smiley face on the sun, sorry. What are those loop-de-loops called, and why were they made, to explain what? You need to know that. As we're kind of moving along, and I really hit this hard, you need to know what those prefix terms are. It's AP, remember that means farthest away. PER means nearest. I'll give you those. All right. As we're kind of moving down through here as well, you need to know, and I talked about this before, where if in one of the starter questions you put a red dot and you put your thumb over it, you extend your thumb out, you close one eye, you cover up that red dot, and then you switch opening one eye to the other eye. What is that called? What is happening there? What is the definition of what is happening? I'll kind of give you the first three letters. It's that, because if I say that, I'm just going to give away the entire answer. You need to know what heliocentric is. Heliocentrism. And geocentrism. Okay. If you don't know that, you've been taking a nap for every single period when I've been blabbering. You need to know what Ptolemy thought as well. Be very specifically to what Ptolemy believed in. Okay, look over your notes for them. All right. One of the questions that we did just talk once about, there was on the quiz. You're going to have a chart, okay? You're going to have some stars. It's going to give you, we might have the distance here. All right, and then we're going to have a parallax. And we're going to give you a couple of those numbers. We might have star A, B, and C, and we're going to say this star is 40 light years away, this one is 60, this one is 100. Then we'll say this one is, I think we're going to say 0.5, we'll say 0.01 and 0.001. And the question they ask is, which one is which? Well, here I am. Guess what? I'm not going to go back and edit this, so deal with it. We're going to be asking what parallax is. Parallax, Say which parallax is the most accurate. And you have to know that. Remember, I always try to set as what I said was, we talked about this before, is what is easier to measure, what is easier to notice. I'll kind of leave it at that. You do need to know what eccentricity is. Eccentricity. Remember, we go from 0 to 1, and you need to know, okay, what is that one's going to look like, and then what is this one going to look like? Is this one going to look more like 0 or 1, or is this one going to look more like 0 to 1? You're going to have to look that up. I'm not giving you the answers. Also, too, as we're kind of talking about orbits as well, I'm going to kind of just highlight these. Hopefully it's still recording. Just going to kind of highlight these. Which one of these is going to be most like our planet's orbit? Is it going to be A or is it going to be B? All right. You need to know, when I do a super exaggerated orbit, we put the sun here. I'm going to say A, B, C, and D. At what point, I will say, is it the fastest, moving the fastest, the slowest? We'll say, when is gravity the greatest, and the weakest, okay? I can't spell. Guess what? It's late, and I don't care. I think you're going to be okay. Aha. Gosh darn it. I don't know if I need a... Maybe I'll ask a sub just to write this down. You need to know, once again, well, you don't need to know. I like using this equation when it comes to the idea of force, okay? So if we increase the mass of something, you need to know what's happening to the force of gravity, all right? When we increase the distance, you also need to know what's happened to the force of gravity. You can maybe just look that up on your own, or you can just do some basic math on it. Another thing, class, there's charts, okay? I'm going to call this gravity on one side. We're going to call this distance on the other, okay? Just pay attention to like what the graph is showing. This means that the closer we are, the greater the gravity is, okay? Whoop. Fart. If I have one that's like this, that's saying that the further the distance is, the greater the gravity is. All right, and just pay attention to one. If it goes like this, or if it goes like this, or it goes like this, just use your gray matter. All right, just don't give on it. Don't give up on it because it's just a pooping graph. Yeah, no, that's really it. That's really it. Hope you enjoyed this cringy video.